The objective of this work is to search for the first evidence of shallow slow earthquakes in Mexico, but also include seismicity, repeaters, and residual gravity and bathymetry to infer properties of the shallow plate interface. All of this to improve our understanding of future large earthquakes in the Guerrero seismic gap. This map shows the subduction zone of Guerrero and major earthquake rupture areas in the last century. The Guerrero seismic gap is located here, where no major earthquakes have ruptured in over 110 years. In Guerrero we have deep tectonic tremors located far from the trench. Also, in junction with tremors we have slow slip events at the plate interface that propagate to the coast. All of these observations come from onshore data. To follow our objective, we have 1 year continuous data from an array of 7 ocean bottom seismometers, located offshore in front of the Guerrero seismic gap. This is the first offshore observation done in the seismic gap. To find the first evidence of shallow slow earthquakes in Mexico, we search for shallow tremors using an envelope correlation method based on maximum likelihood. We detected episodic tremors mostly located at short distances from the trench. Detected seismicity lies close to the coast. There is a clear separation in between shallow tremors and earthquakes, with a region devoid of seismic activity in between them, which we refer as silent zone, most probably an unlocked and freely sliding region. Also, repeaters coincide with earthquakes and with shallow tremors indicating a seismic slip in the areas. One way to identify subducted relief at the plate interface is by interpreting residual gravity and residual bathymetry anomalies. And here we have 2 near-trench tsunami earthquakes overlapping positive anomalies, making it possible for both to be related. The silent zone covers a transition of negative to positive anomalies, where repeaters and most shallow tremors are located over positive anomalies. All of our observations may certainly lead to a better mechanical description of the shallow plate interface. Accounting for frictional conditions, regions prone to stable velocity strengthening and unstable velocity weakening may interact with each other, leading to a variety of sliding behaviors. Now we divide our study area into long deep regions. Inside the Guerrero seismic gap there is region A. Here it is most likely that the episodic shallow tremors are associated with short-term slow slip events. Such behaviors are observed in a conditionally stable domain, composed by a velocity strengthening matrix and isolated velocity weakening patches. In region B, the silent zone should correspond to a stable velocity strengthening domain where strain is released aseismically. Thus, the possibility that a large earthquake nucleates there is lower. Region C is similar to region A, but with down deep slow slip events, so this region should also be conditionally stable. Both regions A and C include significant velocity weakening patches where rapid slip can produce larger earthquakes with magnitudes larger than 6. At farther distances in this region D, we only see slow slip events and deep tremors, thus implying a stable velocity strengthening domain. Outside the seismic gap in the adjacent segment to the west, we distinguish 3 trench parallel regions. A' has the same behavior as region A. However, it rapidly changes to region B', an unstable domain seismically active. At further distances in region C, the plate interface becomes stable because only long-term slow slip events happen. One of the most important differences between the seismic gap and the adjacent segment is that the former does not have a well-developed unstable zone, so a large earthquake will be less probable to initiate there. All of our observations indicate that the central portion of the Guerrero seismic gap is dominated by a weakly coupled stable domain. This implies that the initiation of a large earthquake is less likely to start in the seismic gap. However, we cannot rule out the possibility that the gap could rupture as a result of a large earthquake propagating from an adjacent seismic segment.